So if there's such a thing as inelastic collisions, that means we have to have elastic collisions because we like symmetry, don't we? Okay, so in elastic conditions, objects just don't stick together. So if anyone's played billiards or pool, you know, that they're basically really good examples of elastic collisions, but they're not perfect. So there's actually no perfect elastic collisions, but we can approximate them. We can get pretty close to them. Ice skaters, you know, hitting into each other and then flying apart, that's a really good elastic collision example too. Basically anything where there's like a low friction environment, that's a fairly good approximation of an elastic collision. So the thing with elastic collisions, when things smash into each other, but they don't stick together, so they maybe, you know, we've got some examples here. So we've got like an orange and a white ball. And in the top example, the orange ball it has a velocity of something. So you can see by the size of the blue arrow above it. And the white ball isn't moving. So it has a velocity of 0. When they collide, the orange ball's stopping, the white ball's flinging off. We can get balls like slamming into each other and then rebounding, which is the second example there. We can get two objects moving, one slowly, one tailgating the other one. And that last one's a really good, I guess, explanation of what happens when cars get rear-ended in like traffic jams. So that, like, you're driving along, you're doing, you know, like a reasonable speed, the car behind you is traveling fast, it hits you, the momentum gets transferred to you, and you just like your velocity increases substantially. Okay, so in these situations, in elastic collisions, you can see they're not sticking together, they're flying apart in whatever direction. We're only talking in like linear, like in like, you know, straight lines at the moment. We're going to get into multi-dimensional kind of momentum later and collisions. With these, it's not just momentum that's being conserved, it's also kinetic energy that's being conserved. So the amount of kinetic energy before the collision equals the amount of kinetic energy after the collision. And from that, we can do some really cool like maths and, you know, find heaps of stuff out.